This help video is based on the data logging aspect of the Syvecs ECU range. We're going to cover how the data logging is enabled and what parameters start the data logging and end the data logging, and also cover how to change the configuration for the data logging to enable users to change what parameters are logged and the speed they are logged at. For information, the parameters on the Syvecs range can be logged up to 1000 Hz, that is 1000 times a second on certain parameters. Depending on how many items you're logging this fast, obviously depends on how long you can log for. But to check this aspect, it will be shown in the sconfig later. So the first aspect to look at in the data logging is to find out when the data logging is enabled on your Syvecs ECU. This can be done by plugging in the Ethernet cable into your Syvecs ECU and opening up the software called SCAL, which is open currently. You'll find this on the desktop, and once you actually open it up, what we'll do is we'll connect to the ECU. So the first thing to do is go to the device area and click connect. It will then find your ECU based on your serial number and download the profile which is on the ECU currently. What we want to do now is head down to the logging functions and down to data logging. Here we can set the enable engine speed, the enable throttle position and enable vehicle speed for the data logging to occur. So check to actually make sure that these values are set as you wish to ensure that when you go out and do data logging or anything you're trying to capture data of is set correctly. These items are green, so they can be changed live, and you can also check down here to see when the logging is active in SCAL. Once you've actually got these values set to as you wish, if you are changing them, it's worth speaking to your calibrator first to ensure that it was not set like that for a reason. But if you are changing them, to do some simple testing, make sure that after you've changed the values, you go to device and then program. This will cause the calibration to flash to kick in, and in some instances the fuel pump to run in the particular car. So what we're going to look at now is how to change what parameters are being logged on the ECU. To do this, we need to open up the software called sconfig, which is shown here in front of you. The first thing to do is to actually grab the current config which is on the ECU. To do this, go to device and get config. The serial number presented again, hit OK. Now at the top here you'll be shown the amount of logging time per megabyte that is available on the current sampling bandwidth. Here we'll illustrate how much sampling bandwidth you're using and also the event bandwidth. Decreasing the speed of certain parameters will increase the logging time, so it's worth noting that when actually setting up and data logging the aspects you wish to do. To view the items which are currently being logged, go to View and List Logged. This will show all the items that are currently being logged on the ECU and the speed they're being logged at. The higher the number, the faster they're being logged. So as you can see here, for say cylinder 1 knock values, on this current ECU it's logging at 250 times a second to make sure that every event is captured to ensure that the knock control is set up correctly. Once you've set these to as you wish, and also add other items if they are not currently in the list by going to View and List All, and then applying at the speed you wish the items to be logged at, it's then worth saving this config into the ECU by going to Device and Set Config. This will save the config into the ECU, and when the data logging next occurs, it will log these parameters. The option here is to proceed with deleting existing data on the session ECU. If there is any data that's currently saved on the ECU, this will be deleted when you press yes. If you don't want to delete it, obviously save no, but the stored session config which you've put in won't be saved. So because there's actually data on here which I want to go over how to extract, I'm going to select no here, but in every other instance it's yes. Next we need to open up the program called sdata. This is where we extract the data from the current ECU after the logging parameters have become active. So once you've set the parameters that you wish the logging to occur at, and you've seen that logging becomes active, it is important to then go into SData and extract the data. To do this, click on the device at the top and then read data. Here, enter the download comments for the log you're doing. So for instance, we'll put test 1. And you can also enable a suffix so that in the event you're going to be doing multiple runs on a dyno, you can enable a suffix of enable 001. The next time you don't pull the log off the ECU, it'll be 001 and count up each time you pull a log off. Once you've typed in the data and set everything you wish, hit the OK or F10 and it will download the data which is currently on the ECU. You'll then be presented with 2 warning messages. Do you wish to delete the session data? The data is stored on the ECU constantly, so if you don't delete it, it will just hold up the memory on the ECU. The best thing to suggest here is that at this point, the logs have already been downloaded and pulled off the ECU, as you can see here in green in the location they're saved at. So it's advisable then to clear the memory that's on the ECU by hitting yes, and then the logbook as well, as in yes. This will then open up another logbook comment option for the logbook, which will be explained in another help video, but for this option it's best just to hit F10. The log is then pulled from the ECU, and the easiest thing to do here is then to go to File and Load Latest Data in SView. SView is the data analysis program for viewing the logs. This will then open up the log data on the SView program. To then select which parameters you would like to view, it's easily enough, double click on the item on the right hand side. So say if you would like to monitor your air charge temp, the ACT1, you double click on it. If you say you wanted to be able to monitor your engine water temp, ECT1, double click on it. For a list of all these parameters and what the abbreviated names are, please head to the Syvecs forum and you will find an area which is labelled under the technical documentation and technical deposit, and find that in the sticky there is a section labelling what these are abbreviated to. Now after you've opened up a few parameters, you might find that this current log is not the one you're actually after. Now when SData pulls the logs off the ECU, if there obviously is more than one present, then obviously it will just load the latest one as you chose to do so. So if the current log is not the one you're after, then what you need to do is go up to File, Load, and then select another log based on the date and time that more suits the one you're after. So for example, we'll go to this one, open it up, and then if that's the correct one, obviously we can proceed now with opening up more graphs and explaining a bit more how powerful SView can be. So what we're going to do now is go over how to open and set up a worksheet that you can save on your computer for next time when you come in, quickly opening and logging the specific items you wish to view. So what we're going to do is first of all we're going to open up a section of graphs. So we're going to go Graph, Add, we're going to open up a few more. Now what we're going to do is we're going to make each of these graphs different parameters, like kind of fixing each one. So what we're going to do is say make the top one like maybe engine vitals, the next one down maybe your speeds, the next one down maybe your lambda and manifold pressure. So to do that, you just click on the box of the graph you want, select the items. So let's go down to ECT1, a few EGT, maybe oil pressure, oil temp, and this one maybe we'll have as RPM, manifold pressure, and maybe lambda, i.e. air fuel ratio. And then the next one down we can have as vehicle speed. So you can have, maybe if you wanted to have as your vehicle speed and driven speed. And last one, maybe say your engine torque outputs. So once those have all punched in and saved, you can make it so that all of the other items on the right hand side here are now hidden by pressing the options and key style toggle, which will then just show you the parameters which you're currently viewing. Now if you want to just save this worksheet, what you can do here is go to worksheet and then go new, and in here we're just going to put an example for this one, this task. So I've already got one called examples, we're going to overwrite that, so yes. Then basically, if I was say to clear this graph and go file load, and we'll load another graph, or another log should I say. It will load up, we can then just go to W example, and it will load up the items which you've currently got saved. So then you can click on it at each point and see your different lambdas, etc. All of these items you can change the colours on. If the colour is not what you desire and you need to make it more prominent, you can click on there. Or if you want to put alarms on it, you can set alarms, you can filter them, you can also change the scaling, and also change the units which is being viewed in. So for temperatures you can change to Fahrenheit. For lambda you can change it into different values for this, for like fuel ratio. And obviously speed, you can change this to mile per hour, kilometers per hour, etc. If you want to start being able to overlay graphs so you can compare them, what you can do here is close this down, the graph, this log again, go file load. What we're going to do here is we're going to load, say 1. What we're going to do is now open up another graph, or a graph add, and on the bottom one here we're going to load another log up. So load another. Going to select another log and hit the OK. Once this is loaded, we need to get them in sync together. So the first thing to do is click on the top box, click on RPM, and on the bottom box RPM, but using the other list of parameters. And the first thing we're going to do is actually bring these in time with each other. So as you can see, they're not actually lined up at the moment, so what we can do is click in the bottom box, press the shift, hold down the shift button and drag it along until they roughly read the same. So for example, you can move this to get it as fine as possible. But for the purpose of this video, that's close enough. What we're going to do then now is say, for example, on this particular run we wanted to see on one of the runs it actually caused there was a knock on the engine or detonation. So what I'm going to do is look at the knock traces of each log, and the same on the top one. So you can see on the bottom one here, there's some knock traces that are picked up. What we need to do here is we want to find out why the knock was actually picked up. The actual car was running slightly more ignition timing. So you can see here, it was actually running 15 degrees at this point. It was running actually probably a degree more of timing, which probably caused the knock to occur. But as you can see with the how well the knock control works on the Syvecs, straight away, cylinder number 5, picked up knock, pulled out, 5 degrees of timing, quite severe, pulled it out, got rid of it straight away. Next cylinder, cylinder 4, picked up knock, pulled out because it was less severe, 2.9 degrees of timing, and it's gone. Now the logging software is also very powerful, and in fact you can measure between 2 points, which we're going to go over now. Let's clear the existing graph. And what we're going to look at now is just a simple task of measuring how fast, say, a particular car travels between 2 points. So say if you wanted to measure the time distance between how long it took from the car to accelerate from 60 to 130, you would hit the 60 option here, press the space bar, and then travel to the next point and click, and your delta is viewable here. So you can see this car got from 60 to 130 in 3.5 seconds. You can see the distance it travelled at that point, and obviously the highest vehicle speed. Okay, I hope this has been useful to cover the basic aspects of SView. Obviously the SView is a lot more powerful by having the ability to add math channels, track mapping and many more, but for the general purpose of getting this helpful to general customers that need help with logging, I hope this has been useful.